Solar energy is the most abundant energy on planet Earth. To efficiently harness and convert this energy into electricity, a device called a solar panel must be adopted. The first commercial solar panel was created over 140 years ago by an American inventor named Charles Fritz. For a solar panel to work perfectly, it needs to follow some principles of photovoltaic effect. Solar panels are typically made of silicon, a semiconductor material, and also the second most abundant element on Earth. The silicon is processed and divided into thin layers, known as silicon wafers. The silicon wafers is what is used in creating a photovoltaic cell, which is simply known as a solar cell. A solar panel is composed of many solar cells, and it is what converts solar energy or sunlight into electricity. The solar cell is divided into two silicon layers. The upper layer is made up of a mixture of silicon and phosphorus, called the N-type silicon. The bottom layer is made up of a mixture of silicon and boron, called the P-type silicon. The meeting point of these two layers is known as the p-n junction. In this situation, all the silicon atoms are bonded together. The electrons are also not free to move. This prevents the flow of current. The N-type layer has abundant electrons, whilst the P-type layer has abundant spaces to accommodate electrons, known as holes. At the junction between the N-type and the P-type layers, an electric field is automatically established due to the movement of electrons and holes across each other. This is known as the depletion region. Now, light is composed of numerous tiny particles called photons. When a single photon from the sunlight strikes the surface of the solar cell, it causes one of the bonded electrons to be released, leaving a hole behind. This process is known as the photovoltaic effect. The electric field at the depletion region acts as a one-way gate that directs the movement of electrons to the N-type layer and holes to the P-type layer. When the sunlight is intense, more photons strike the surface of the solar cell and release more electrons, leaving behind more holes. Just like how the opposite regions of magnets attract each other, the electrons and the holes also attract each other. If a channel is created to connect the layers together, electrons will move from the N-type layer to fill up the holes in the P-type layer. This movement or flow of electrons is known as electric current. It is what powers electric objects. However, this type of current is a direct current. Most household appliances and the electrical grid operate on alternating current rather than direct current. Therefore, the direct current produced by the solar panels is often converted to alternating current using an inverter. The electricity generated can be used immediately, stored in batteries for later use, or fed into the power grid. Solar energy systems often include batteries to store excess electricity generated during sunny periods, ensuring a continuous power supply even when sunlight is not available. The efficiency of most commercial solar panels is typically between 15 and 20%. The most efficient solar panel so far reaches approximately 46% efficiency. When vast amounts of solar cells are connected together, it is called a solar module. When multiple solar modules are connected to each other, it is called a solar string. When multiple solar strings are connected to each other, it is called solar array. While the initial cost of installing solar panels may be high, they offer a solid return on investment over their lifespan, typically ranging from 25 to 35 years.